Okay, there we go. All right, so today we're still talking similarity and talking about ratios and proportions and all that good stuff. But today, instead of just talking the basics of similarity, we're going to actually use similarity to find missing angle measures and side lengths and things like that. So go ahead and grab your notes and let's get started. And okay. 8.1. This is part 2. Similarity and ratios. Okay. So, like we kind of talked about before, we can use similarity to find something called that similarity ratio, right? And when what we want to be able to do is use that similarity ratio to find side lengths and angles that are missing on one of our two shapes. So today our goal, use similarity to find missing measures. Okay, and so the easiest way that we can kind of do this and go through the steps is with examples. So our first example. And there's actually a couple of different ways that we can do this. I'm going to show you 2 ways, and you can choose your favorite. So for our example, we have triangle ABC and triangle DEF. And we are told triangle ABC is similar to triangle DEF. We are told the side lengths over here are 3, 6, and 8. The side lengths over here are 6 and 12. And we are missing one. We're going to call that X. And we are being asked to find the value of X. Okay. So when we're doing a problem like this, step 1 is pretty much going to be figure out which sides are corresponding. And what we want to do is kind of set up these ratios with the corresponding sides. So remember, like yesterday, we saw the whole AB comes first and DE comes first. So we put AB over DE. That's what we're looking to do here. We want to set up something like this: AB over DE, and then BC over EF, since those are the last 2 letters, and then AC over DF, since it's the first and last and the first and last. So that's step 1, set up something kind of like this. Step 2, we're going to use this to find the scale factor. So we're going to fill in the ratios above to find that similarity ratio, or the scale factor, if we're thinking of it kind of like we did in terms of dilations. So I'm going to fill in whatever information I have here. I know that AB is 6. So I'm just going to kind of write that above what I know. I know DE is 3. I know BC is X. I know EF is 8. I know AC is 12. And I know DF is 6. That's all from the picture. Okay. So that similarity ratio is going to be one of these where I have both the number on the top and the number on the bottom, kind of like we were working with yesterday, finding that similarity ratio. So in this case, the similarity ratio, AB over DE, is 6 over 3, which is 2. Or you could use the flipped version, the similarity ratio. In this case, this is the similarity ratio of ABC to DEF. If you did it the other way around, if you did DE over AB, you would get 3 over 6, which is 1/2. And that's the similarity ratio for DEF to ABC. So that's another thing that we talked about yesterday. So these are our similarity ratios, or our scale factors. And this is where we can split apart into two different ways of solving this thing. So the first way, I'm going to call the scale factor way, or the similarity ratio way. Similarity ratio method. So basically, I have two similarity ratios here, right? I have 2 and 1/2. Out of those two, which one's bigger, 2 or 1/2? 2, right? So the one that's larger is what you would multiply by to make it bigger. The 1/2 makes things smaller. So what I want to do is take the side on the one that I know that corresponds with the one that I don't and multiply it by whichever one that I need. So if I look back up here at my picture, I'm looking for this missing side here, X. The side that goes with it over here is 8. Now is this triangle is the smaller triangle. So I want to take this and multiply it by the bigger scale factor to make it bigger and make it fit in with this triangle over here. So what I would do here is take EF is 8. If I go 8 times 2, my larger scale factor, or my bigger similarity ratio, that gives me 16, which gives me BC. So this was kind of a long-winded way to explain that this triangle is half the size of this one. So if I take this one and multiply it by 2, I get this triangle over here. Also, you could do this another way. We could take our ratio up here. We had that, I'm going to call this the, it's a slightly more algebraic way. We had AB over DE and BC over EF. If I fill those in, we had 6 over 3 and X over 8. And this is something that we can solve. So if you've seen problems like this before, what we had to do was cross multiply. 6 times 8, which is 48, equals 3 times x, which is 3x. Then we have 48 equals 3x, so we divide by 3 on both sides to get x is 16. So BC is 16. So those are kind of the two different ways that you can do this. This way involves a little bit more thinking in that you need to make sure that you're multiplying by the correct scale factor and you're getting bigger if you would like, if you need to make it bigger, and smaller if you need to make it smaller. This one involves a little more upfront work with figuring out your ratios and all of that, but then becomes a simpler solve as you go down. Either way of doing it is fine. Um, any questions so far? Any numbers we're not sure where they came from? Any steps we're not sure how they happened? Okay. Then we're gonna do some more of these. Get some more practice here. Okay, so for this one, we have A, B, C, D is similar to E, F, G, H. H. All right, and let's see, we're going to be told this one, this one. And oops, sorry guys. This one's supposed to be 21. My bad. And let's see, we're supposed to find, if we can find all of those off of this. Find X, Y, and Z. Okay, so for this one, first thing we want to do, just like on the last one, set up our corresponding sides. So for this one, A and B are the first two letters. E and F are the second two letters. Or are the first two letters over here, excuse me. B, C are the next two letters. F, G are the next two letters. C and D are the last two letters. G and H are the last two letters. And then A and D are the first and last letter. E, H are the first and last letter. Then we want to fill in the ratios. So with whatever we're looking for up here, or with whatever we've got labeled on the sides up here, we want to fill those in. So AB is Z, EF is 4, BC is 6, FG is 2, CD is 4, GH is X, AD is 21, and EH is Y. So once I've got those kind of written in above where they go, I'm going to fill that in down here. We have Z over 4, 6 over 2, 4 over X, 21 over Y. Okay. So out of all of these, the only one that's completely filled in is this one here. 6 over 2. That tells me that my similarity ratio is 3 or 1/3, depending on which way I'm going. Okay. So remember, we had two methods. We had the similarity ratio way, that was the first way, and we had the algebraic way, that was the second way. So just out of curiosity, off of our first take here, did you like the first way or the second way better? Go ahead and answer in the chat. What do you prefer, just based off of that first problem that we did? All right. Looks like most of our votes are for the first way. With this one, I'll continue to show both ways. But we'll try it the first way first. Okay. So our similarity ratios are 3 or 1/3. So this one is bigger. 1/3 is smaller. So kind of step 3 down here, showing it the first way. I'm going to take my other proportions. We had Z over 4, we had 4 over X, and we had 21 over Y. Okay. And then knowing our similarity ratio was 6 over 2, or 3, or 1/3. Another way that you can kind of think of this is the larger number is on top, the smaller number is on bottom. So on all of these, the smaller number should be the one on the bottom, the larger number should be the one on top. So looking at this first one, am I going to need to multiply this by the larger scale factor or the smaller scale factor to get the number on top? What do we think? Am I going to have to multiply the 4 by and make it bigger, or multiply the 4 and make it smaller? Yes, make it bigger. You can also kind of tell because this ratio here, the Z over 4, that was AB over EF. So Z is on the larger shape, 4 is on the smaller shape. So we need to multiply this by the larger scale factor to get it over to the bigger shape. So I'm going to take 4 times 3, which gives me 12 for Z. All right, and we've got 4 over X here. 4 over X comes from that CD over GH. X is on my smaller shape. 4, the CD side, is on my larger shape. So am I going to multiply that by the big scale factor or the smaller scale factor to get X on the bottom? I need to make it bigger or smaller? So looking at my picture, I'm solving for x, and x is on the smaller shape. So if x is on the smaller shape, we need to make it smaller. So this time I'm going to multiply by 1/3, which gives me 4/3 for x. And then same thing goes over here. We have 21 over y. Y is on the smaller shape, so I need to multiply by the smaller scale factor. So I'm going to take 21 times 1/3, which gives me 7, which is y. So that's the first way. You can take the variable, if it's on the bigger shape, then you need to multiply the corresponding side by the bigger scale factor. If your variable's on the smaller shape, then you multiply by the smaller scale factor to make it smaller. But why? Yes, good job, Caleb. Okay. The second way. What I would do for the second way is take this ratio that we know, 6/2, and I'm going to set it up into 3 different equations because we're solving for 3 different things. So I'm going to say 6/2 is equal to z over 4. I'm going to say 6/2 is equal to 4 over x. And I'm going to say 6/2 is equal to 21 over y. So we're setting up 3 equations here. And then we just cross multiply for all of these. 6 times 4 is 24. 24 equals 2z. Actually, I'm going to set that up there instead. Then I would divide by 2 on both sides to get 12 equals z. Same thing goes here. 6 times x is 6x. 4 times 2 is 8. Dividing by 6 on both sides, we get x equals 8 over 6, which is equal to 4 over 3 if you reduce it. Then for y, we'll do the same thing. 6 times y is 6y. 21 times 2 is 42. Dividing by 6 on both sides, we get y is 7. Okay. So that's both methods again. I don't care which one you use. Whichever one feels more comfortable to you is the one you should probably go with. Any numbers we're not sure where they came from so far on this one? Any steps we're not sure how they happen or why they work that way? Okay. I'm going to give you guys one to try now. You can use whichever method you like better, and then we'll go over it together. Just kidding. All right, so for this one, you're finding X and Y. So go ahead, give this one a try. When you think you've got both X and Y, type got it in the chat. And I'll kind of give us little hints along the way if anyone gets stuck. If you started off with those ratios, you're on the right track. CA should be over DO. AT should be over OG. CT should be over DG. Then go fill in those numbers that go with it. All right, if you filled it all of your proportions in, that's what they should look like. 6 over X, 8 over 12, Y over 6. So you're on the right track if that's where you ended up. Then you've got two different methods to choose from at this point, the proportiony algebraic way or the scale factor way, or the similarity ratio way. By the way, the similarity ratio here, you could call it 8 over 12, or you could reduce the fraction here, which is what I would do. Because they're both divisible by 4, so you get 2/3. Or 3/2 for the larger one. If you're doing it the second way and you set up 8 over 12 equals 6 over x and 8 over 12 equals y over 6, you're on the right track. You could also use 2 over 3 equals 6 over x and 2 over 3 equals y over 6. That would also work here, since you can just reduce the fraction. All right, anyone think they've got it so far? So doing things the second way, we would cross multiply. We'd get 8x equals 72. Or if you're doing it this way, you could get 2x equals 18. Either way, when you divide on both sides, if I divide by 8 here and here, we get x equals 9. If I divide by 2 here, we also get x equals 9. Whichever, if you choose to reduce the ratio first or not, you should still get 9. Same thing happens here. We get 48 equals 12y. Or if you cross multiply here, we get 12 equals 3y. Either way, here we would divide by 12, here we would divide by 3. You get y is 4. Okay, and then the same thing should happen here if you chose to do it the first way. Remember, x is on the larger shape, so I'm going to multiply by the larger scale factor, which is 3 over 2, which is then 18 over 2, which is 9 for x, just like we got using the second method. Then we look for the next one for y. Y is on the smaller shape. So for the smaller shape, we multiply by the smaller scale factor. So 6 times 2/3, since 2/3 is the smaller scale factor, which gives me 12 over 3, which is 4 for y, just like we got using the second way. Okay. Hopefully this is starting to make a little bit more sense now. Any questions, comments, concerns before we try another? Okay, let's do one more. This time it's going to be a little bit more like a problem that you'll see on your homework where there's not quite as much stuff to find, and where we also might be throwing in there finding some angles and things like that. So for this one, PQRS is similar to WXYZ. This one, we've got some angles in the picture. And we'll have some side lengths as well. We'll go with this one is 12. Over here, we've got 9. And we'll say this is 8. And we are going to find YZ and the measure of angle W. Okay, so sometimes you'll see questions phrased this way instead, where you're finding YZ and you have to look at the picture and kind of assign YZ a variable on your own. Um, so for this one, the first thing I would do is assign YZ some kind of variable. Maybe I'll call it T. So that when I go and set up my ratios, I can have something kind of useful there. Okay, so go ahead, give this one a try. I'll give us hints along the way again, just like last time. Or WXYZ. Oh, this is 134. Sorry, I know it's kind of tiny. So if you started off with something like this, you're on the right track. First two letters over first two letters, next two over next two, last two over last two, first and last over first and last. Then we're filling in what we have. Notice if you don't have something for a particular side, that's okay. We don't need to, especially if you're not even asked about that side, you don't really need to do anything with it. We're just looking to fill in what we do have. And so in this case, all we really have is 8 over t and 12 over 9. And so this one's actually perfectly set up to do it the second way right off the bat. You can do it the first way if you want to, but this one's already set up perfectly for the second method. So for this one, you should get 6 equals t, which means that yz, the side we were asked for, is 6. So actually, t isn't what we were really looking for. You want to replace that variable again with yz. Okay. And then what's the measure of angle W going to be? Anyone know? Anyone have a guess? Requires us to remember something from yesterday. Yes, 52. So remember, yesterday we talked about corresponding angles are still congruent for similar shapes. So if I'm looking for the measure of angle W, W is the first letter, it's going to be exactly the same as the measure of angle P because P is also the first letter. So we know measure of angle W is equal to the measure of angle P, which is 52. So the measure of angle W is also 52. So we get angle W is 52 and YZ is 6. Okay. We're going to do a quick poll, if it'll load. There we go. Okay, so on a scale of 1 to 5, how are we feeling about what we've learned so far today? 1 being needing a lot of help, 3 being I probably just need some practice on my own, 5 being I know this so well, I could probably teach it to somebody. So go to the poll section and let me know, what are we feeling right now? Everybody please vote. No one's going to see what you voted, just me. But if you're out there, I need you to vote. This is also kind of part of attendance, so make sure we put our vote in. You have to click on the 3 little shapes up in the corner and then click on polls. All right, you got 30 seconds. All right, 3, 2, 1. All right, if you were unable to vote or unable to find the polls, let me know in the chat. So that I, make sure we account for you. Otherwise, looks like we had a pretty good bell curve going there. With mostly people saying that they wanted to try practicing on their own. So that's what we're going to do. We're going to take a look at the assignment together real quick. And then if you would like more help or more examples, you can always stick around and we can go over more. But if you would like to work on your own, you'll have the opportunity to do so. So I'm going to post the assignment. Today's assignment is a big ideas assignment. So let's go ahead. You might have to refresh your Google Classroom page. There it is. All right. Looking at the big ideas assignment, go ahead and click on that if you can handle, or if your internet can handle a Google Meet and a big ideas at the same time. If not, just look at mine for a moment. Okay. So we'll see things like find the scale factor of the figures, just like we did yesterday. The scale factor, the similarity ratio, those are all kind of the same thing. Find the scale factor of the figures, then list all pairs of congruent angles. And then write the ratios of the corresponding side length in a statement of proportionality. So we're basically filling in what we have been doing for the first step of our problem the whole time. So looking from here to here, we know DEFG is similar to PQRS. So the scale factor or the similarity ratio, you might want to take like DE over here. DE is 9 over PQ, which is 3. So 9 over 3, which gives you 3 for your scale factor. Then what does angle D go with? Angle P, the first letter, both of them. So then you'll fill in based on the letter order. Angle E goes with angle Q, that sort of thing. And then down here, we're looking for the ratios that will go in here based off of our letter order here. So DE is going to go with PQ. So we want to find the one where DE and PQ are together, like this one. Or EF and QR. We want to find the one where EF and QR are together. So then you'll go through doing the same thing with your other FG and RS or DG and PS, finding the ones where those are together. Oh, and this one they didn't, that's kind of annoying. They didn't specify where, if they wanted the scale factor to be from this one to this one or from this one to this one. So if that happens in this case, I think they're just looking for 1/3, which is the other version of the scale factor. Yeah. Okay. Anyways, there are a total of 11 questions. Make sure you use that check answer feature. That little checkbox in the corner lets you know if you've got the answer right or wrong. You've got 4 checks for each of them. So, and then beyond that, you can always change the answer. It just won't tell you if it's right or wrong before you turn it in. So, if you have questions or need help with any particular problem, make sure you ask that question in class tomorrow. Otherwise, if you would like more examples or would like help with anything, feel free to stick around. Otherwise, you are free to go and work on your own. And have a good rest of your day.